So today we are going to learn about internal capsule. Internal capsule is a V-shaped white matter structure present in the brain that acts as a two-way highway for nerve fibers connecting the cerebral cortex to the lower brainstem and spinal cord. So the nerve tract that connecting between the cortex and the lower parts of the brain is known as projection fibers. So internal capsule is a type of projection fibers. So that part is written here. Internal capsule is a compact band of projection fibers that's situated in the inframedial part of each cerebral hemisphere. So it carries both ascending, that is sensory, and descending motor fibers. So superiorly it continues as the corona radiata and inferiorly it continues as the crus cerebri of the midbrain. So because of the numerous fibers are packed into a very small area, a small lesion even can produce extensive neurological deficits. So coming to this figure, so here we can see the internal capsule here. This is the internal capsule. This white matter is the internal capsule. So now we can discuss about the parts of the internal capsule. So this is known as the anterior limb. This is the anterior limb. Before that we can learn about the relations of the internal capsule. So this is the medial side and this is the lateral side. In the medial side it have supromedially it have the head of the caudate nucleus and inframedially it have thalamus. In laterally it have the lentiform nucleus. So coming to the parts, it have anterior limb. This is genu. Here is genu. This is posterior limb. This is sublentiform part and retrolentiform part is behind the lentiform nucleus. So the relation of the anterior limb is medially head of the caudate nucleus and upper part of the lentiform nucleus. So genu is the bend between anterior limb and the posterior limb. Then comes the posterior limb. It contains medially thalamus and laterally lentiform nucleus and the sublentiform and the retrolentiform part. Now we can discuss about the fibers that are seen in internal capsule. So there are, as we said, there are motor fibers and sensory fibers. Motor fibers can be discussed in three headings, that is corticopontine fibers, pyramidal fibers and extrapyramidal fibers. So the corticopontine fibers are easier to remember. They arises from the four lobes, that is frontal, parietal, temporal and occipital, and then they get ended in the pontine nuclei. So its name become frontopontine, parietopontine, temporopontine and occipitopontine. Then the pyramidal fibers. They include corticonuclear and corticospinal fibers. The corticonuclear fibers from the cerebral cortex to the nuclei of the cranial nerves. And also corticospinal fibers that arises from the cerebral cortex to the spinal cord. Then some extrapyramidal fibers. They include they connect between the cerebral cortex with the ret nucleus, substantia nigra, reticular nuclei and olivary nuclei. So coming to the sensory fibers, we have thalamocortical fibers. They are also known as thalamocortical fibers. They include anterior thalamic radiation, that is from the anterior and dorsomedial nuclei of the thalamus to the frontal lobe. Then comes the superior thalamic radiation. They are from the ventral thalamic nuclei of the thalamus to the primary sensory cortex. Then the inferior thalamic radiation, they also known as auditory radiation. The auditory radiation from the medial geniculate body that you have been already studied in the pathway of the auditory pathway in physiology. They arise from the medial geniculate body to the primary auditory cortex. So the inferior thalamic radiation is the auditory radiation. Then the posterior thalamic radiation, that is optic radiation, that arises from the lateral geniculate body to the primary visual cortex. So now we can learn about from which part of the internal capsule where these fibers are arising from. So first we can discuss about the anterior limb. On the anterior limb, the fibers arising, the motor fibers are frontopontine and the sensory fibers are anterior thalamic radiation. So their function is to connect the frontal lobe with the pons and the thalamus. So that's about anterior fibers, anterior limb fibers. Then the genu. Genu, as we discussed earlier, it's a band between the anterior and the posterior limb. So the fibers present here are the motor fibers include the corticonuclear fibers, and the sensory fibers include the anterior part of the superior thalamic radiation. So their function is to carry motor fibers to the cranial nerve nucleus, that is the corticonuclear fibers. Then the posterior limb. The posterior limb also have motor and sensory fibers. This is the motor fibers that include corticospinal fibers, that is upper limb fibers, trunk fibers, lower limb fibers, then corticopontine fibers, then corticorubral fibers. Then for sensory fibers, superior thalamic radiation, that is from the globus pallidus to the subthalamic nucleus. So as they are carrying a major of motor and sensory pathways, the most clinically important part of the internal capsule is the posterior limb. You have to remember. So next is sublendiform part. The motor fibers arising from here are the paretopontine fibers, temporopontine fibers, which connects between the temporal lobe with the thalamus. Then comes the ascending fibers or the sensory fibers. They include inferior thalamic radiation, that is the auditory radiation, and fibers, and also its function is to carry the auditory impulses. Then the last part, that is the retrolendiform part. The fibers, motor fibers are the occipitopontine fibers, and the sensory fibers are posterior thalamic radiation, that is the optic radiation. So their functions will be, they carry visual impulses. So this is all about the fibers of the internal capsule. So there is a box that is given in Vishram Singh. I think that will be more than enough for you guys. Then study the figures also. Then coming to the blood supply. Blood supply is also important. So the blood supply, mainly the blood supply supplying the internal capsule are the medial stride branches of middle cerebral artery, lateral stride branches of middle cerebral artery, and stride branches. So coming to, we can discuss about the individually about the parts. So the anterior limb, it supplies the anterior limb is supplied by the recurrent artery of the Hübner and the direct branches of the ACA. Then the genu, it's supplied by the direct branches of the internal carotid artery and the posterior communicating artery. So the this is the basilar artery, and this is the posterior cerebral artery. This is the internal carotid artery. Here from this arises the middle cerebral artery. So this is the internal carotid. So this is the basilar artery. It joins to form posterior cerebral artery. So this is the posterior communicating artery. Posterior communicating artery communicates between the posterior cerebral artery and the internal carotid artery. So that also supplies the genu. So coming to the next part, that is the posterior limb. It is separated by the medial and stride branches of middle cerebral artery, the lateral stride branches of middle cerebral artery, and anterior carotid artery. Then the sublendiform part, they are also supplied by posterior cerebral artery, anterior carotid artery. Then the retrolendiform part, it's supplied by the posterior cerebral artery. We can show it in the figure. So this is the internal carotid artery. Here the internal carotid artery. The internal carotid artery, from there arises the middle cerebral artery. From middle cerebral artery, lateral and medial stride branches that supplies the posterior limb. From anterior carotid branch also arises from the internal carotid artery. It also supplies the posterior limb. So that's all about posterior limb. Then from the anterior limb, from the internal carotid artery arises anterior cerebral artery. The anterior cerebral artery reaches to form a direct branch and supplies the anterior limb, and also the recurrent branch of Hübner also supplies the anterior limb. Then for genu, there is a direct branch from the internal carotid artery and also the branches from posterior communicating artery. So here is the basilar artery, that forms the posterior cerebral artery. That's all, and this is the posterior communicating artery. Then for the sublendiform part, branches from the anterior choroidal artery and branches of posterior cerebral artery. From the figure you can easily learn this is from the anterior choroidal artery and also from the posterior cerebral artery. Then from the retrolendiform part, it is from the branches of posterior cerebral artery. So this is all about the blood cells. So for the clinical anatomy, we have discussing about the lesion of the internal capsule. So as we discussed earlier, even a small lesion produces widespread neurological deficits because of the numerous fibers are densely packed. Then Charcot's artery rupture. Charcot's artery is the lateral striate branches that supply the posterior limb. So it produces contralateral spastic hemiplegia, that is UMN lesion. Then the recurrent artery of Hübner, which supplies the anterior limb and the genu, it produces contralateral paralysis of the face and the upper limb. Then anterior choroidal artery thrombosis. It affects the posterior limb, sublendiform part and retrolendiform part and produces contralateral motor weakness, homonymous hemianopia and auditory defects. Now coming to the a quick revision. The shape of the internal capsule is V-shaped with the lateral concavity. So it's a projection fiber. It's continuous dust. Above as corona radiata and below as crus cerebra of the midbrain and genu. And for the anterior limb, the most important fibers are the corticopontine fibers. Then for the genu, it is corticonuclear. Then posterior limb, corticospinal. Sublendiform part, the auditory radiation, and retrolendiform part is the optic radiation, and Charcot's artery is known as the artery of the cerebral hemorrhage, that is the lateral striate branch that is supplying the posterior limb. Then the recurrent artery of Hübner, it supplies the anterior limb and the genu. Then remember that the small lesion of the internal capsule can cause extensive neurological defects. So that's all about internal capsule. Thank you.